Brenton is joining. Chris is CEO of Active Countermeasures. Yet again, another person that whenever I'm kind of in his presence, I sometimes have to pinch myself that I'm in the same room with Chris. Many people don't know this, but Chris is the first SANS instructor I ever took a class from. And he absolutely blew my mind and made me realize just how badly I sucked at security. So I strived to get better. And then years later, I became an instructor. I'm like, great, now I can hang out with Chris. Nope, still not there. And then he was working at Dine, and I talked about a new product we were working on. And he goes, I'm going to work on this project whether you like it or not. And we haven't been able to get rid of him since. So now he basically just runs the project. Yeah, and I like the hair coming back, man.
That's what I was about to say. And the really cool thing about Chris is I have hair envy. The man has some hair.
He's got chops. It's on fire.
But my COVID haircut or lack thereof. I think it's been many, many months at this point. So
it's kind of funny though. I had somebody yesterday tell me, it seems like as a lot of information security, quote unquote, luminaries get old, they just stop doing technical presentations. And I basically responded back to them. I said, wait till tomorrow.
Yes.
Why? Part of the reason why I like, working with Chris so much is he still takes me to school on a regular basis. So this is one of the most popular blogs that we've ever had at Active Countermeasures. And there's been some really kick-ass blogs like the Malware of the Day blogs. Been doing really well. Yeah. Keith Chu's been putting those together.
He's doing awesome. Yeah.
But these Tshark blogs, like there's so many people, they know of Tshark, but they don't know the magic of Tshark. So Chris is going to drop some of that knowledge on y'all right now. So Chris, take it away.
Happy to. So we leaving cameras on so they have to deal with us or not during these things?
Well, it's up to you, Chris. You can your lovely hair.
Oh, God, no. Make the camera go away. I don't want to scare people.
All right, take it away, Chris.
Awesome. Hey, folks. Yeah, so as John gave that great introduction, I'm Chris Brenton. Appreciate everybody turning in or turning out for this. I posted this in the Discord channel. So the quickest way to probably get this information is probably to just copy paste it out of Discord and kind of go at it from there. But everything I'm doing, I figured it would make it a lot easier if you could just kind of follow along and play the home game on this whole thing. So get your favorite flavor of Linux up and going. Of course, I say any flavor of Linux, and then I give an Ubuntu-specific command to actually install Tshark. So, call me out on that if you want. You can replace app with yum, but you get the idea. You're going to need Tshark on the system. The wget file is just going to pull down a tarball. I promise I can't say there's nothing evil in it. There's evil packets in it. They won't do anything evil to your system. They'll just be fun to look at because they're evil. But then open up that tarball. You should end up with 2 PCAP files. 1hr.pcap I'm going to cover as part of this talk. 24hr PCAP is for you to kind of go back through later. What I wanted to do is to kind of walk you through the process, use a smaller data set just to kind of keep it easy, and then give you a bigger data set to go through and process after this talk just to kind of get comfortable with. And the slides are in Discord. And some upcoming classes. So some of this content is actually based on a network threat hunting class that we've pulled together. We've got a basic class that we offer for free, runs for about 4 hours. That's the first bullet. And then we've got a 2-day class that we actually just got finished running one of those. That runs for 8 hours. That's the third bullet. And I've got a leadership class that I'm teaching too. Go way back in my history, and there were packet capturing tools. One of my first internet jobs was every Friday I downloaded the host file because DNS didn't exist yet. Oh my God, that's scary. But one of the first packet capture tools most of us are ever exposed to is TCP dump. And TCP dump is a great tool. I still go back and use it on occasion. The limitation with TCP dump is the output you get out of it. You kind of get what the programmer thought would be good information for you to be looking at, and you get a little bit of control over it. I can add -v, -vv, -vvv to kind of change the decode level that's coming out. I can do a -x. Let's say all I want to look at is source IP address and the IP ID in each packet, and that's the only thing I want to be able to say. I can't do that with TCP dump. I can say -v, and then I'll get the IP ID, but there's going to be a ton of other information in there. And if I actually want to kind of script something to process that information to do something useful with it, oh my God, I'm now in cut hell, right? Trying to get through all the different fields. So nice tool for basic stuff, but Tshark just makes this so much easier. Think of it as like the SaaS solution of packet capturing. You can go in and you can customize this to be exactly what you want. Really nice. So you can go in with this and you can say, okay, don't show me everything. In this particular case here, I'm just going in and I'm identifying about 6 different fields that I want to say, and then that's the only thing that's getting printed out. Makes life a whole lot easier, especially if you want to get into doing some level of automation. So, for example, one of the things we were looking at in the threat hunting class yesterday is we were going through and we were looking at some UDP traffic, and we were trying to look for heartbeat versus activation of a command and control channel within that traffic. And one of the ways we went about doing that was just going in and saying, show me how much data was transmitted. Now show me how many times that data size was transmitted versus anything else. That'll give you an idea of how often was that backdoor actually activated. So you can do some really cool stuff once you start running this through like sort and unique and cut and stuff like that. So I'll talk about that as we go through. So what's this let you do? It lets you get the exact fields you want to work with and in the exact order that you want them. I notice most people, myself included, tends to kind of select the fields in the order that they would normally get printed out at if we were looking at everything. But you can mix anything around any way you want to. Like I was talking about, messing with data size. You can have that be the first thing that prints out, so it's way at the left-hand side. So now when I go through and I start sorting things, I don't have to use -K to just define a specific column. I can just do it right on the first column because, hey, I moved all the data I wanted over there. So that makes it really cool. The other thing that's kind of nice about it is it kind of automatically ignores anything that I'm really not interested in. So for example, let's say I go in and I tell TCP dump, I want to see all the DNS queries and all the DNS answers. And that's all I want to see. Well, if a TCP 443 packet goes by, well, there's no DNS in that, so it just ignores it. So it'll print a blank line on the screen and that's it. Well, blank lines are easy to clean out, right? But at least I don't have to go sorting through to try and figure out where's the actual data I want to work with. So that's kind of a really nice feature. And again, once you go in and you start wanting to kind of manipulate this information, this makes it a whole lot easier. Let me back up for just a second here because we got a good example of the command here. So I'm running Tshark, -R, load the capture file that I want to work with. I can do this live as well, by the way. I'm saying -T fields. So the -T field is what indicates, hey, I want to extract out and only look at specific fields. Don't just print your normal summary. This one is optional. -E header equals Y. If I want these spiffy little headers along the top, because I'm going to be looking at the output, yeah, I can go in and I can hit set header equal to Y. It's set to no by default, which most of the time is kind of useful because, again, usually we're going to be going in and manipulating this data, and we don't want to have to try and clean out the header information if we don't have to. Just don't specify it and it won't show up. So once I say -T fields, then I can go in with -e and specify the exact fields that I want to say. And again, I can do this in any order. It's pretty straightforward to go through and do. The hard part is keeping track of all of these. But there's some good references out there. I'll show you that as we go through. The one thing I do want to kind of point out, just because you'll see it on slides on occasion, in case you haven't run into this before, but notice I pumped the output through head. By pumping it through head, I'm saying, show me the first 10 lines of output. Don't show me everything. And the reason I did that was to make sure, hey, look, this packet capture actually fits on this slide because there's actually a couple of hundred lines that would have been printed otherwise. When I pump things through head, it'll go through the first 10 lines like I specified here, and then it'll just kill the output. It'll kill the stream. As soon as it kills the stream, you see this. You see this error. It's a little misleading because it makes it look like Tshark just generated an error. And Tshark kind of did. It's trying to print things to the screen, and it can't anymore because I just cut that off. But this whole broken pipe thing, that's just strictly because of the head. Not a big deal. How do we go about specifying fields? -e. And the typical syntax here is header dot, a field within that header, and then dot, and then maybe some sub of that, some sort of data type. So I can go in and I can say, like, I want to look at the TCP flags. I can go in and specify only certain flags that I want to look at, or I can choose to look at the entire byte if I want to go in and look at it that way. One thing I will just kind of give you a heads up on is a lot of this stuff, like the flag fields, are going to print out in hex. So when they print out, you're going to have to kind of know off your head how to convert that into decimal in order to be able to figure out what field is which. But it's not that big of a deal to go through and do. Sometimes I'll have multiple options. So for example, here I'm saying I want to look at the HTTP header. Okay, so a couple caveats here. Number one, Tshark is not application aware. So when I go in and I'm telling it the HTTP header, it's going to look at TCP/80 and try and pull that out regardless of whether it's actually HTTP or not. The second thing, which is also kind of cool, is I can go through and sometimes I have different options for how I want to display things. So for example, here I'm saying I want to see the HTTP request, but all I want to see is the URI. That's it. I don't want to see the fully qualified domain name that was part of the full URL that was entered. Here I can say, no, show me the full URL. So again, sometimes one piece of information is more useful than the other. I can go through and I can cut and slice these any ways that I need to. Well, geez, Chris, how do I keep track of all this stuff? In other words, like I said, there's a lot of different fields that we could potentially go in here and specify. How do we find that type of information? A couple of useful links for you. This PDF from Packet Life I would not be surprised if it isn't like one of the most downloaded things on the internet. That is used by everybody. It has the most commonly used display filters in there, or at least at the time it was created. I'm noticing that there's some things that people tend to kind of look for that aren't part of that cheat sheet because they weren't popular at that time. It might be time to do a refresh on that. But if you want to get to everything, go to the second link. And oh boy, when I say everything, I mean everything. There are thousands of these things that you can go through and specify. But again, they're usually not too hard to go through and find. So again, if I want to look at like TCP flags, I know, well, hey, that's a field in the TCP header, so I should go to the T section and then search down for TCP. And then once I find that, I can click that link, and that'll open up all the different options that are available within the TCP header. I know I want to look at the flag field, so let me go look at the flag associated ones, and I can drill right in and find what I want. So again, it can seem a little overwhelming at first, but it's actually not that bad once you get used to it. So specifying the fields, I already talked about this, showed it to you as an example on a command line. This is just an additional reference for you to be able to go through and use. The Tshark Mantra, sort, unique, sort. Although quite honestly, this is a lot of different people's mantras. If you're doing auditing, this is your mantra. This comes in handy a lot. What this, a lot of times when we're printing stuff out, we don't necessarily want to see the raw data, or we don't want to see each individual line item. We want to look at like accumulation of the whole thing. So it's nice to be able to go through and kind of create summaries. Like I might want to look at what are the most popular websites that people are going to. Well, that doesn't mean I want to look at every unique session or every unique packet to kind of run that down. It's kind of like a summary that just adds it all up for me and does that nicely. This is where sort, unique, sort comes in handy. The first sort command allows me to go through and kind of combine things together, and there may be different switches I need to use. I'll expand on that a little bit later. But the first sort command basically organizes the data in the way that I need to go through and organize it. Unique-C takes matching line entries and then drops that down to only a single line entry, but then it adds a numeric value in the left-hand column to identify how many entries did actually exist. So imagine I go through Tshark and I say I want to print out the source address and the destination address. Source IP, destination IP. That's the only thing I want to print out all the way through. And then I want to go through and let's say I want to get an idea of how often was everybody talking to each other? What were the busiest sessions taking place type of thing? I could go in and I could say, first run it through sort. And what that will do is anytime 192.168.1.10 was talking to 10.1.0.15, all of those lines will end up right next to each other. And I need them together in order for unique to do its magic, because when it changes to a different set of values, unique just writes things out and assumes it's done. It doesn't actually maintain state through the whole file. So sort kind of organizes all my data together. And then unique-C is going to go through and say, hey, 192.168.10, talk to that system 15 times, because there's 15 lines in the output. And what unique C will do is it will go through and change that to just be one line, but then it'll print the number 15 on the left-hand side. Sort-RN. So I might do sort-N, I might do sort-RN. It depends upon what data I want to look at. So for example, in that case there, I wanted to see who was talking to who. Well, I might be most interested in the busiest sessions that are taken. Sort-N says look at that value as a numeric value. By default, it's going to try and deal with it as alpha characters, and we want it to look at that number 15 as a number, not as an alpha. So we need to specify n. That way it knows to process it as a number. R says do a reverse sort, so put the largest number at the top. So again, if I want to see what are my busiest sessions, what are the busiest systems talking to each other, R is going to put those right up at the top of the list. Now, maybe I'm looking for things like unique user agents on my network. So I might go through and tell Tshark, extract out the user agent field from the HTTP header, and then I want to go through and I want to sort that. I want to do a sort-n at the end, because I want to actually have the most unique ones at the top, not the most common ones at the top. Because typically when we're in looking for user agents as a potential, being used as a backdoor, it's the unique stuff. If everybody's running Windows 10 in the same version of Chrome, we don't care about that user agent because everybody's using it. It's the one-offs that we may want to pay the most attention to. So you'll see us leveraging this set of commands quite frequently when we go through and we work with this Tshark output. So here's Tshark just going in, kind of reading the files the same way that like TCP dump would. Now, if you're following along and you're playing the home game, you should be able to just go in and run this command and get the exact same results that I did. So I'm just telling Tshark, hey, read in that 1hr.pcap file, pump it through head-5. So head-5 says just print 5 lines worth of output. Bang, you should end up with what we have here. Okay. So here I'm saying read that file, -t fields. So I want to specify what I want to see. -e, I want to see the IP source address. -e, I want to see the IP destination address. Then I'm going to sort them. So this is that example that I just kind of talked through. I'm going to sort them so that anytime anybody's talking to each other, those end up next to each other. And by the way, if this is like the first time you're playing around with this stuff, go through this kind of removing portions of the command. In other words, if I've never done this before, type up everything up to this first slash. So type in just the Tshark command and that's it. And then let that output scroll by the screen just so you can see what that looks like. Now add in the first sort command. How did that change what the output looks like? Now add in the unique -c. Now add in that. Now add in that. So you get the idea. Step through this we're running multiple commands against this data. Step through each command just to see how it goes through and changes it and makes it more presentable. So once we run it through everything, we end up with something like this. So within that 1H PCAP file, these two systems here are clearly the busiest, right? They're right up at the top of my list. My next line entry is blank. What does that mean? I'll come back and talk about that in just a second. Notice that for the most part, I've got pairs, and the pairs tend to have about the same amount of traffic going back and forth. That's common, but it's not uncommon to see something slightly different like here where one side sent only about 1/3 as much traffic as the other side. You do run into that type of thing on occasion. Now, blank line, what's that mean? Where'd that come from? Here's what that means. So remember what I said about Tshark. When I print out specific fields, it's only going to print out the stuff that matches what I'm looking for. So if I say show me DNS queries, it's only going to show me DNS packets that have queries in it. If I go in and I say show me HTTP, URLs or URIs, it's only going to show me HTTP packets and the URI value that's inside of it. Everything else gets ignored and it prints a blank line. Well, there were 2,959 packets that did not fit this criteria right here. Print this IP source address, IP destination address. It's not noticeable specifically here, but what we're actually talking about is just IP version 4. That was the version of IP that this thing was first developed on. So there was no reason to say, IPv4.source, IPv4.dst. So when you don't see the version of IP provided, assume it's just IP version 4. There may be IP version 6 packets in here, and that's why I don't see them. They don't meet this filter criteria. There might be IPX traffic on this network. There might be NetBUI traffic on this network. Those are different protocols. They're not IP-based. Those are going to end up in here as well. So you get the idea. The only thing we're looking at is IPv4 traffic. Everything else is ending up in this blank line area here. And here's just an example of some of the stuff that ended up in that. So this time I went through and said, okay, show me IPv6 source address, IPv6 destination address. I went through and did the same thing. Now I'm ignoring all my IPv4 traffic as well as everything else. And I can see I've got a little bit of IPv6 traffic on the network, but this is all multicast traffic. So it doesn't appear like there's any actual IPv6 communications taking place. It's just systems that have an IPv6 stack assigned to them, and they're just saying, hey, someone talk to me, I'm sad and I'm bored, and I feel like people are ignoring me. So this time I went through and said, okay, so let's look at things that are not IPv4 and not IPv6 and see what's there, just to see what else might happen to be on that network. And notice we're seeing a lot of layer 2 protocol communications. So we're seeing a lot of spanning tree taking place. So this is just, a switch that's out there saying, hey, I'm a switch. Are you a switch? If so, we should hook up and make sure we don't loop packets, because looping packets would be bad, and whatever else switches say to each other when they're on the network and people go home at night. I'm not really sure. I don't probably want to know. But you get the idea. Okay. Try these 2 commands. And you can see they're pretty much the same, but I want you to kind of just see what the difference in the output looks like between them. So here I'm saying tshark-r 1hr.pcap-t fields -e http request full_URI. Pipe that through head and then pump it through head and just limit it to 5 lines. When you run that, you're going to see something in the output that is kind of not a pain, but kind of a pain, or something we don't really care about. Then try adding in this command here and see how that output changes. For the grep savvy in the audience, and I know there's a lot of you, you're probably looking at that command saying, oh yeah, I know what that does. I know what that does. Let's look at the example, and I'll kind of talk you through what it does. So here was the first command I typed. So I said, go in and I want to see the full URL out of these things. Remember what I said. Anytime I see a packet that doesn't match it, I'm going to get a blank line. Well, guess what? Most of the traffic does not have an URL inside of it. So most of the traffic is going to be blank lines. Well, this is kind of a pain, because now I'm going to have pages and pages of blank lines, and that just does me no good at all. So here's what this grep command does. And notice as soon as I run that grep command, I start seeing just the URIs and nothing else. Let me talk it through based on the last one, because this is just a little bit easier to read. So grep-v says, show me everything but. This is super useful. So there's times that I might want to, say, spit this output out, and I might be interested in only traffic associated with a specific IP address. So I may do my Tshark Fields, print that information out, and let's say I only cared about JPEG files. I might say grep space /JPEG. And now the only thing that'll print out is any full URIs that actually have a JPEG that's associated with it. -v says everything else but. So if I said -v /JPEG, now it's going to show me every line but the JPEG file. So I'm doing a -v here, which says I'm telling grep I want to ignore something. What is it I want to ignore? The -e is allowing me to go in and define a blank line. So what I'm saying is filter out anything that's a blank line. If it's a blank line, don't print it. Everything else, print that out instead. And then run that through head, and that's why we're now seeing all of our data. And the only thing we were printing out is data. We don't have any blank lines to work with. Making sense? If not, feel free to just kind of toss it into Discord. Okay. So this time what we're going to do is we're going to add in our mantra. Remember, sort, unique, sort, that's our mantra. Let's go in and apply that here to see how it might be useful. So the command here is the same here. I just wanted to make sure it was fully legible to everybody. So I'm telling Tshark, read in that capture file. I want to specify fields. The only field I'm specifying is the full URL. I'm running it through grep-v-e $, so get rid of those blank lines. And we saw what that output looked like here. So now we're ending up with output that looks like this. And now what I'm doing is I'm running it through sort. What's that going to do? What sort is going to do is it's going to go through and grab any time the URL or the URI is the same, it's going to combine all of those together. It's going to print them out right next to each other or one above the other type of thing. Then I'm saying unique. So unique-c. So now that we've got them all combined together, unique-c will truncate that down to a single line and print a number that tells me how many times was that line actually seen. Then I'm saying sort space -rn. So I'm saying sort that output, putting the most frequently visited URI at the very top. And I get output kind of similar to this. So what are we looking at here? Well, get a couple things going on. This one, let's start at the bottom and we'll work our way up. So this one here looks like it's going off and maybe checking a DigiCert digital certificate. Not a big deal. This one looks like I'm running Windows 10 and I've got a tile that checks the local weather and updates my screen to show me what the local weather is. That's not a big deal. This one is kind of annoying. Notice it's going to a multicast address. So this is, if I remember correctly, I think this is unplug and play. So I think this is like Windows systems trying to modify firewall rules and do all sorts of things that maybe we want to let it do, maybe we don't. Eek, I hate it when this happens. And then we got this one here. So 117 times in this file, somebody went to this URL. Now, a couple of things stand out at me about this URL. First, it's a JPEG file. Why did we need to load the same JPEG file 117 times? That's kind of odd. The other thing that strikes me is to notice that for this fully qualified domain name, this is the only time the URL appears. Meaning, someone didn't go to the index.html file at this website, and the index.html file said, hey, go load these JPEG files over here. That's not what happened. Someone did a direct connect to that JPEG. Why? That's rare. Now, maybe there's like a silly cat meme, on this site, and people link to it to show it in other things like Slack or whatever. That's a possibility. But I would be really surprised if a cat meme was being stored underneath the admin directory. That's another thing that's kind of flagging this for me here. It's going to the admin directory. That's weird. The other one that sticks out for me, look at the fully qualified domain name. So it looks like Mahaima Life Sciences. But notice the L has been replaced with a 1. Ooh, it's Elite Speak. It must be an awesome website, right? No. Someone, I think, has gone in and created a phishing site. In other words, there's probably a legitimate site that has an L for life sciences here, and someone's trying to make their site look like that site. So the 1 instead of the L, that's suspicious. It's under the admin directory, that's suspicious. Loading the JPEG file directly, that's suspicious. And doing it 117 times, that's super suspicious. Notice how quickly we found that data. So by just going in and saying, show me the full URL and show me what's most popular, I was able to go in and see, hey, there's something in here that may be worth going in and paying attention to. So this time we're going to go in and look at, hey, what are the most popular DNS queries? What DNS queries are we doing most frequently? This is a good one for finding like C2 over DNS. Typically, when someone's doing C2 over DNS, the domain name that's getting hit is going to be hit more often than just about anything else. And the other unique thing about it is you're going to find that there are thousands of fully qualified domain names associated with that domain that you've been looking up. That also makes it kind of weird. So Tshark, read in that capture file, -t fields -e DNS query name. So all I'm looking up is, hey, what was somebody doing for a DNS query? I'm using my grep command to get rid of those blank lines. sort unique sort, and I want the most matched one at the top. And, not surprising, the most frequent stuff taking place here is Microsoft stuff. And then, we get down into here and we're going to load up our weather. So we're loading our weather like 6 times an hour probably. GLive, there's a lot of Microsoft stuff in here. And then down here at the bottom, we looked up some IP addresses, tried to reverse them back to the fully qualified domain name a couple of times as well. But again, I didn't have to go through all the different sessions. This automatically zoomed right in on anything that was DNS related. All right, so what if I wanted to look at long connections? What if I want to go and look at who's talking to who the longest? So here's the problem. Tshark output is per packet based, right? Typically, when I'm looking at Tshark output, what I'm looking at is just a bunch of packets going back and forth. If I want to get into duration for a TCP session, I need to know when was that first SYN packet sent and when was that final acknowledgement that acknowledged last FINAC sent. That's my duration of communication. And oh my God, if the packets are going by and I'm trying to pull this out of the timestamp field, it's going to be a real pain in the backside. So one of the other cool things I can do is I can go through and I can have Tshark do that work for me. If you have not played around with -Z, do it. -Z is really cool. It allows you to go through and generate all sorts of cool statistics. I mean, there's a lot of different areas you can go in and kind of zoom in on. By default, it will print out everything it's reviewing in the file and then print out the summary. So when I ran this command, it would actually print out everything and then down at the bottom actually start printing out the duration summaries. That's not really helpful because I'm going to have a lot of data that I don't really care about. That's where the -Q comes in. -Q says, don't show me the data you're processing, only show me the results that you generated. And try this. Try just printing out this. I try running just this command here and that's it. And you'll go through and you'll see what does that output actually look like. Generating that output, I'm running it through, clearing out blank lines. I got another way to go about doing it here. And then I'm going in and I'm saying cut -D using spaces is my delimiter between lines. And what I'm telling cut is I want to pull out fields 1, 2, 3, and 10. So run this command, take a look at that output, and what you'll see is that, well, and actually I keep saying that, and I should just run that command for you, right? That would make life easier. So that's what my output ends up looking like. Let's pump that through less. So actually, let me do a couple things here. So let me first get rid of -Q. So you can see what happens. And see, first what I get is all my packets going back and forth. So I get all this data up at the very top. And then when it gets to the end, that's when I'll finally get my summary. Well, if I do that, it's going to make it really hard to go in and kind of clean it up, right? So it's a little bit easier if I go through and I use my -Q to say, just don't bother showing me any of that output. So what actually gets printed out is my timestamp, who was talking to who, how many frames, how many bytes were going in each direction, what was the total going back and forth between them. So if I want to look at total duration between two systems, what I really care about is the source IP address, the destination IP address, and how many bytes total was actually traded between those systems. Make sense? So now let's go back over here and look at this command again. So what I'm pulling out is the source IP address, the destination IP address. Well, actually, source IP address. I'm pulling out the little funky greater than, less than, greater than, because, hey, that looks kind of neat, doesn't it? So that's field 2. Field 3 is my destination IP address. Field 10 is my duration and time. Then I'm saying sort -K4. Okay, there's a new variation we haven't talked about before. In RN, we talked about that. Reverse sort, look at things numerically. But what's the K4 do? What K4 does is normally sort would start sorting on the left-hand side, right? It's going to try and sort the whole line. What we're telling it is, I want to skip to the 4th column. So 1, 2, 3, 4th column, which is my duration, and I want to sort on that instead. Well, that's going to put my longest connections up at the very top of this list. RN, reverse order sort. So biggest number goes in the top. So if I want to see what are the longest connections taking place on my network at any given time, and I've got a PCAP file, I can go in, run this command, and that'll very quickly print that up for me. Practice your toe. Yes. So I've given you a bunch of exercises in here. So we've gone through and we've walked through this using the 1hr.pcap file. And what that file is it's actually just a 1 hour PCAP. Let me show you here. Boy, sometimes it's tough typing around a mic. So here's a summary of the 1hr PCAP file. So this one here, I've got, if I go in and I look at my first capture, last capture, what's important is my duration. That's almost exactly 3,600 seconds or 1 hour. So the 1hr is a 1 hour PCAP. Hey, guess what the 24hr cap file is? Anybody want to guess? Yeah, this is my 24-hour capture. So 24 hours would be 86,400 seconds. So I'm 2 seconds shy of 24 hours. Close enough for what we're doing. So we just walked through it using a 1 hour capture file. I wanted to give you the 24-hour capture file just because there's more data in there to process. There's more data in there to kind of deal with. It's going to take a little bit longer, or there might be a little bit more cleanup you need to do in order to be able to go through and kind of take care of that. But everything we did with the 1 hour capture file is directly applicable to the 24-hour capture file. It just gives you a chance to be able to go in and just kind of practice with that. Any questions at this point? We're down to about 13 minutes. I wanted to leave a lot of time for questions, mostly because, as John said, this has been a really popular blog entry, which tells me people are trying to solve an awful lot of problems with this. So if you've got a question, please feel free to just toss it into the Discord channel. How would I go about automating this? Oh, awesome question. Awesome question. So how would you go about automating this? Kind of depends upon what is it you want to go through and automate. So for example, is this a situation where I'm seeing, let's say, all my traffic going in and out of my internet link, and I want to go through and run some reports on a regular basis to be able to kind of feel like I'm getting some good visibility on what's taking place. You could go through and run this, kind of live and filter things out, but you're only going to be able to run one type of report. So your only other option would be run it as a PCAP and then do multiple passes against that PCAP looking for different things. So I may do a pass looking for interesting URIs. I may do another pass looking for DNS queries versus DNS answers. You get the idea, or I can go through and do it that way. Now, with all of that said, if it was me doing it, I'd use Bro. I'd use Bro/Zeek. It used to be called Bro. It's now called Zeek. It's a little bit easier to deal with, and it processes data more quickly. If I've got a 24-hour capture file and, there's 10 million packets in it, I need to process 10 million packets to go through and do one of these searches that we're talking about here. If, however, I'm using Bro is summarizing out every unique session. There's a lot less data to have to go in and work with to be able to find the information that I want. So to kind of answer the question, how would I automate this? If it was stuff that I was going to be doing on a regular basis, let's say I knew that I've got a bunch of PCAP files and I know I'm going to be running this a lot. What I would do is I would create a brand new command. Let's say something like show dir, SHOW-DUR or something like that. And the show dir command would be used anytime I have a PCAP file and I want to go in and find out what the duration is. What I would do is give you an example. So I'm just going to take the command. I'll take the whole command. Go. So here's what I'm going to do. I'm going to say echo. Well, I'm going to first have to spell echo correctly. Paste in that command. And then I'm going to output that to, I forget what I was saying. I was going to call it. I'm going to call this CHKDUR, just to have a file name here. And what that just did is it wrote that command out to that text file. Now notice I made one change. Instead of specifying the capture file name, I just went in and named it $1. Now what I'm going to do is I'm going to make this executable. Now what I can do is, let's say I want to go in and I want to check that 24-hour file. Rather than having to type that whole command out again, all I have to do is run my checkdir command, specifying the file that I want to look at, pass that in as a variable, and then choke on me. Why is that choking on me? Oh, God, I hate live labs because I always mess something up. Choking on that. Let's try that. Look one more time here. Missing operand. Well, so I'd have to go through and troubleshoot this. I'm clearly messing something up. Sorry about that. I'm not sure why this is puking on me. I'd have to go through and kind of play around with it, but you get the idea. I can go through and I can make this an executable command, use a variable to go in. So as far as like automating the ability to go in and like check for things like the duration of all of my connections inside of a file, I could go in and simply do something like this. Assuming I don't typo, and clearly I've typoed something in this. So missing operand, I'd probably just start removing some of these commands until I figured out which command is actually messing up, and then just go in and pick it up. Let's see, what else we got here? Bro is amazing. Yes, Bro is totally amazing. Very good tool. Very good tool. There's some timing issues with it we found. Speaking of long connections, Bro uses a 5-minute timeout. And what we found is that sometimes, especially when you're trying to find command and control channels, the command and control channel may call back to its command and control server, transmit data across it, and then sit and do nothing for a while, and then go in and check in again later. BroZeek by default has a 5-minute timeout. So if that pause is more than 5 minutes, Zeek will just go through and write a log entry out, assume it's done, and then the next time the thing transmits, it creates a new log entry and gives it the flags OTH, which basically says, hey, I'm seeing a session here, but I never saw the 3-packet handshake, and I'm not sure why. And if you go through and line them up, you see, yeah, it's the same port numbers each time, and this thing's just killing on the session. But that's fairly easy to go in and just change the default TTL timeout from 5 minutes to like an hour. And that fixes that problem. But yeah, Bro is a great tool. I have AI Hunter running. Yay. That tool has been an awful lot of fun to develop, and we still got some fun things going on with that too. Demo cods require sacrifice. Yeah, no kidding, right? Where's my chicken when I need it? Extra space in the command. Yeah, that may have been it. Next PCAP and ELK, but Tshark is great for doing our... Can I just take all this stuff and throw it into ELK and do it that way? Sure you can. That is a possibility. I think we sometimes ask too much of ELK. It seems to be kind of the go-to thing now, right? Because it used to be, go back many, many years, and any security problem could be solved by throwing a firewall at it. And now it seems like any security problem can be solved by just throwing the data in an ELK stack. And it takes a little bit more than that. We also need to be kind of mindful that, ELK stacks are super useful, but they do have their maximums. And the more data we shove into it, the slower our queries run, the slower it indexes, the harder it becomes to get out the useful information we need in order to be able to catch the bad guys. So we want to be careful going through and doing that type of thing. TR is missing the quotes. Oh, hey, you're right. That's awesome. That's weird. Oh, I know why it's missing the quotes. It's missing the quotes because I used Echo to put that thing together. That's why. Oh, awesome. So Cryptos, you get the Cupid doll for the day. That's a great catch. That was a great catch. Did I see a Joff?
Yes, it was the rare Joff sighting. You sound like you're getting towards the end there, Chris, so I thought I'd pop in.
Yes, I am.
See how you're doing. So, yeah, fun talk. I love the.
Actually, just one last thing I wanted to cover before I finish, just real quick. You can stay on, dude. It's only going to take a second. Which is, come on. There we go. So yeah, after this slide is all the answers for doing this on the 24-hour capture file as well. So both of them are in there. So even though I didn't cover the 24-hour file, it's all in here. I just want you to do it yourself before I actually show you any answers.
Very good, sir. Thank you so much.
Thank you.
I love the hands-onness. One of my favorite things about Hackin Fest is all the labs and the hands-on stuff, and I was concerned doing it all remotely we would lose some of that. So thank you, Chris, for bringing that back in a talk. That's awesome that people got to type and see things.
Hey, if there's a way to be handsy and not get in trouble with HR, I'll find you.
Wow.
Well, that's setting the tone there. Oh, my goodness.
You guys have HR at ACM?
Yeah, I can see the back room now. My God, why did we let Chris have a live mic?
Yeah, no kidding, right?
It's supposed to be over now. Over.
Yes.
No worries at all, Chris. So.
No, that was great. That was really great. This is the kind of thing that it has to be muscle memory almost, or it's not so useful. If you have to go back and look up every single one of those things every time you do it, you're not going to do it. So talks like this are, I know I'm preaching to the choir here, but these are fantastic. It just makes you do it once, and now it's easy to get into it next time when you have a real PCAP to look at.
Yeah, agreed. And quite honestly, that's a lot of the reason why I script a lot of this stuff, because I can usually figure out from my nomenclature what the command does, but to remember all the switches to kind of pull it together, yeah, that's a tough one for me.
Yeah, syntax after a while, and I like to say, and I think I'm in this category right there with you, Chris, that I think I've forgotten more than I've learned. And when you get to that point in your career, you know, the buffer has just overflowed so many times that, yeah, sometimes some syntax just slips out the other side. So stuff happens.
Well, and Joff, so you've been at this you've been at this a long time too, so you've probably run into this. The worst ones are when someone mentions they figured out how to do something. You hear what they describe and you're like, oh, I'm not sure how to do that. Gee, that sounds kind of interesting. Let me check it out. They show it to you and you realize, oh, wait, I did know how to use that 10 years ago. I've just forgotten since then.
Yeah. I even do it when pen testing sometimes. Like, oh, what was I doing? You know, the other day I was looking for something and I'm hunting around the internet and then I find my own blog entry. It's like, wait a minute.
Me too. When I ever look for something to do, whenever I look for something to do, I find Joff's blog posts too.
Yeah, so it's a good thing I wrote it down because it wasn't up here.
There's the secret, Joff, right? This is the only reason we write blog entries, because we know we're just going to forget this stuff later, and that way we've got a reference.
Yeah, well, I mean, I've tried telling my wife everything, but I think her buffer has overflowed as well, so it's not working. I mean,
different priorities there.
Yeah, different priorities.
Yeah, exactly.
So
hey, Chris, there's a question in the Discord. I think is a good one. In the spirit of making this operational, so like using this over and over again, where's your favorite place to monitor the network to get the PCAPs in the first place? So maybe not at a corporate environment where there are rules, but maybe like at home, or how would you suggest somebody get their own PCAPs to do exactly what we just did now?
So if you're just starting out and you're trying to like figure this stuff out, and you're in a position where your job role does not allow you to collect this type of data. So let's say we're not in a corporate environment and I'm a security person that's allowed to go in and monitor the network. I'm some other job role and I'm trying to come up to speed on this stuff. Home network is absolutely the way to go. Bill Stearns did a webcast over on active countermeasures. I'm going to say about 3 months ago, but the way time goes these days, it was probably more like 6 months ago. But it was how to build a home lab. And he goes through and kind of talks you through, hey, buy this Linksys managed router for managed switch for like $40. And now you can actually put a network tap into your network to be able to see the packets going by. And, you know, here's how to go through and build up a Pi sensor that's a really cheap way to go in and run Bro or Zeek to be able to go in and monitor what's going on in your network. But yeah, start at home. The challenge a lot of folks run into is most of us kind of start off with that box that our cable modem provider gave us. that has, wireless built in and everything else, your best bet is to stop doing that. First of all, go off and buy your own box, because you can probably buy the box you're paying $15-20 a month for. You can probably replace for like $50-60, and now you own it and you don't have to pay that lease fee anymore. But break out the functions. So have your cable modem just be a cable modem. Have your wireless access point be on a wireless access point, and now have that run through your switch. Now you can actually see everything going on in your wireless as well, not just the wired part of the network. So yeah, definitely go in and start there. And one of the things I love about that is that if we try this at work and we mess up, people who control our financial security get mad at us, and that's never a good thing. If we try this at home, we're probably going to piss off our kids because we've just killed Netflix or something, and they've got to deal with us. They have no choice. So
Right.
Yeah, so I'm a really big proponent of experimenting on your family. It definitely has worked before. Although again, my lovely wife has said, "Hands off my machine." She sets a boundary. But I have to admit, I did use it for a little pivot experimentation the other day. But I did tell her. But anyway, so great talk, Chris. Really appreciate bringing the hands-on back to it. That's definitely a good thing to have. And I really love. Oh man, do I really love seeing some command line? I mean, that's bringing the action there, right? And Tshark. A lot of people don't realize this. I did this years ago. I met Mike Poor. I blame Mike Poor for it now. Tshark.
We all blame Mike Poor for many different things.
We do, and Tshark is just it's so high performance. It's an amazing tool compared to TCP dump. I know we all love TCP dump for historical reasons, but Tshark really is an amazing tool. So that was super cool.